Hey guys, what's up and welcome to the 8th video in the C# tutorial series. So the last video we looked at switch statements as a way to execute some of our code in particular situations. And this video, as I mentioned in the last, we're going to be taking a look at loops in C#. Okay, so C# pretty much allows for 4 different kind of loops. One of them we're not going to concentrate too much on because it's more for I enumerables, which we're going to focus on later on in this tutorial series. So we're going to be focusing on 3 of the 4, all right? Now, let's dive right in. The first one is going to be the while loop, okay? And like most programming languages, the while loop doesn't differ much, really much at all, okay? But we want to see how it's used, okay? So we have a condition, and then inside of that, if that condition suffices, inside of this block is when the code will execute, okay? So while anything inside of this is true, we want to execute this code. And a lot of it's the same. It's just a condition that is like the if, so we can put an expression inside of here like this, or if 2 is greater than 3 is greater than 2. So anything that will result into a bool will be able to be put inside of these parens, all right? Now, with this, we want to make sure that we are cautious with infinite loops, and that's in a loop that will never execute and will always execute and never break out, okay? So something like this would not execute or break out, okay? So we'll say infinite loop. Oh no. All right, so it will go into the end of time or until your electricity bill just runs out, because it will never end, all right? So we want to make sure that we're always cautious when we're using loops, and C# is no different, all right? So let's go ahead and just like make a little example of using a while loop, all right? And then we'll use something called loop test equals 0. And we'll just do something like if loop test or while loop test is less than 10, then we want to output to the console. We'll output actually loop test plus plus. So we'll increment it while we're actually outputting it. And this will, we started up, this will output 0 through 9, so 10 numbers, 0 through 9. And then it will then check once it's 10 is not less than 10, and then it'll break out, all right? So that's really all there is with the while loop. Now there's a counterpart, a DoWhile, all right? And then the DoWhile loop, really the only way that the DoWhile differs is that its expression is checked after the statement block. So therefore, because it's checked after, it's guaranteed to execute at least once, all right? So C# does support a DoWhile loop, and it looks like this. Here is your whatever's inside of your statement block. And then you have, of course, your while, and then you want to make sure you have a semicolon at the end of your condition, all right? So just this structure of it can show you that it's going to execute this and then check the condition, and even if it's is true or not, it will continue. But even if it's not true, it will execute at least once. So if we run this guy, we'll see that it actually does not look anything different because it's running the same way as the while loop. However, if we change this to say something like 15, right? So 15 is obviously not less than 10, so the while loop would never execute, but the DoWhile obviously executes once. So it does execute and then it checks. So it comes into here and says, okay, print out loop test, which was 15, and then, okay, while 15 is less than 10. Oh wait, that's not true. Break out and then continue with the rest of the code. So that is something where if you want to use and to keep in consideration when you want to have something execute at least once guaranteed, all right? Now, the next and final one that we're going to talk about in this video is, of course, the for loop. So the for loop is something that's used, probably the most commonly used loop, actually, because it's just, it allows for a lot more clean code, all right? So instead of initializing and then incrementing, we could do that all inside of the body of a for loop by providing an initialization clause, a condition clause, and then an iteration clause, all right? So that looks something like this. We can do int loop test, so therefore we declare it, we initialize it, semicolon, and then we give it the condition in which to execute, okay? So like we did in the while loop, loop test less than 10, semicolon, and then inside of the body of the while loop, but where we increment it, we can now actually do it inside of the body of the parens of the for loop, all right? So all of this now is done inside of here. So anything inside of here is actually just full-on code. And that's really nice because of the fact that, you know, when you're writing code, it's a lot simpler to read or to write, and then when you're reading it, it's a lot simpler to actually read. So it naturally is just a more common loop to use because of its cleanliness, all right? So there you go. And then now if we execute this, it will obviously do the same thing, 10 numbers, 0 through 9, all right? So it's just simply the way that it's formatted in the syntax of the for loop that really just makes it more popular. All righty? There you have it. So now that we have, you know, a hold on some loops in C#, you know, what can we do with them, you know? And one thing that I would like to implement is the 21 game that we were talking about in the other video, the previous one. So just to get rid of like the monotony of the console application and all that, it's fun to actually have reason to build something. So when you kind of just go one by one on something, you don't really have a project or something you're working on, it can get really monotonous, especially for me. And that's just the way I am. So I like to have something that I can kind of, you know, not sure how to do it yet. And then when I figure it out, I'll do it with C# or whatever programming language I'm using. And to me, that's the best way to learn, is to have something that you need to get done. So let's make a game. Let's make a simple 21 blackjack game, okay? And it's not going to have all the bells and whistles because we still haven't gone over arrays and certain data structures and classes and stuff like that will make it a more robust game. However, we can implement something rather simple with the tools that we have as of right now, all right? So let's go ahead and get rid of this code because we're not going to need it, since we're not going to need to try parse, because we're actually going to implement a random number generator, okay? So what we're first going to have is we're going to call it what's going to be an integer. We're going to call it a player card value. And that's going to start off as 0, okay? So when the game starts, the player has a card value of 0, okay? And then like in 21, if you're not familiar with it, you're usually always playing a dealer, okay? So you keep on hitting until you have a card or a value of your cards of 21 or lower. And then if you go over 21, you bust. But if you get at 21 or very close to it, the goal is to get as close as possible, if not on 21. And then have the dealer will then try to match that or beat you and maybe bust and maybe not, okay? So you have to go first, your turn is first, and then the dealer who you're playing against then goes and tries to match and then of course beat your card and maybe tie, beat, or even bust, and then you will win, okay? So you have your card value, and then you have the dealer card value. So let's go ahead and make a type of random, okay? And we're not going to concentrate too much on this, but just know that this is a variable of random type. And what it does for us is has a method called next that we can then use to generate a random number between 1 and 11, okay? So what we're going to do is we're going to do player card value plus equals, okay, next, and then the integral is going to be 1 to 11, okay? So it's going to be from 1 to 11, give us a random number of 1 through 11, okay? So there's three signatures that you can use, but we're going to be using the third, okay? All right. And do know actually that the next is the min value is inclusive, okay? So it includes that value. But the max value, if we did 11, it would not include, it'd be 1 through 10. So we want to actually increment 1 through 11. So what we'll do is, see how it says the exclusive upper bound, okay? Max value must be greater than or equal to a min value. So we'll do 12, okay? And this will generate, so we'll do random number from 1 to 11 is what that will generate for us, okay? And since the player gets 2 cards, what we want to do actually is we want to do this twice, okay? Because the player gets 2 cards, so we want to emulate them getting another card. So what we can do is simply copy and paste this. And then we want to do the same thing for the dealer. But first, notice that since this gives us a value from 1 to 11, it's possible to bust right away, okay? And obviously that's not the case because the ace card, the 1 or the 11, can be a 1 or 11 in depending on the favor of what the favor goes towards for the player. Okay, so if they're gonna bust, they want to make their ace a 1. If they want to jump it up, then they want to make their ace at 11. So we don't have that implemented yet, and we're not going to in this because it's going to be a really simple example. But let's go ahead to prevent that. At least we'll do if player card value is greater than 21 as soon as they hit, which could be 22 at the max, then we want to actually decrement their card by 10. Okay, making their one of their, because they must have an ace 11. We decrement by 10, which makes their ace a 1, which is what they're obviously going to want to have. Okay, so we're going to have a better way to implement that later on the tutorial series as we learn more, and we will be able to have further control over that. But just for now, let's go ahead and implement it that way. So we're going to have our dealer card value, and we're going to do the same exact thing. We'll do next 1 through 12. And then we'll do the same exact thing again to emulate 2 cards, because the dealer does get 2 cards. One's up, one's face down. However, we're not going to really worry about that right now. And then of course we're going to want to check for the same thing so that the dealer doesn't bust right away. So if it is greater than 21, decrement by 10. And these are just things that, like, you know, we're using ifs. So I want to just take everything that we have knowledge of right now and kind of just use it, okay? And including the loops, the if conditions, the, you know, the integers, everything that we've learned, and what can we do with that. And I think that making a simple game will be pretty fun, okay? So here we have the player's turn, okay? And the player's turn is going to be emulated by a while loop, okay? So we're going to do while true. And this may look like an infinite loop, but we're actually going to have break statements that are going to break. So when you have break, it actually breaks you from this loop, okay? It's immediate parent loop. And what I mean by immediate parent loop is if there was another true here and we had break inside of here, then what would happen is it would break from its parent loop, this one, and then it would still come into here though. So it would still be in an infinite loop, just of the parent loop, not the second loop, okay? So that's just kind of what that does. But remember, it is for its immediate loop, its corresponding one. Now, what we want to do now is we want to let the player keep hitting until they reach 21, or if they're comfortable at a number close to 21, or if they bust, okay? So we want to have some values and some conditions that may be met, and depending on what happens, we want to deal with them, okay? So the first thing we want to do is we want to check to see if the player card value is 21, because it's possible for them to have 21 as soon as they start the game. So what we want to do, if it is 21, we'll do you are at 21. Yay. And we want to break because there's nothing to do for the player's turn. They're obviously at 21. They're going to want to stay, right? So that condition may be met. However, if it's not, what we want to do is you want to actually tell the user their card value, okay? So we'll do my card value. All right, to string. So it's the string, the card value, and then we'll ask them if they want to hit or not. So we'll say hit question mark, okay? So they're not at 21. They're obviously not over 21. So do they want to hit yet? Do they want to keep going? And what we'll do is we'll do string answer, and then we'll do console read line. All right. So the answer, which we're reading a line, okay? So remember we did that in the previous tutorial, okay? So what we'll actually check for is a Y for yes, okay? And then we'll check for, we'll do an else if, and we'll say, okay, if it's not Y, is it no? And then if it's not that, it's not either of them. So what we'll do is we'll say incorrect response, try again. And here's what we'll do. We'll do a continue. Okay? So a continue in while is what continue does in C# is it takes you to the beginning of the loop. No matter where you are, even if there's code that's left, so if there's code right here, say like this, it's going to skip all that, and it's actually going to just go straight into the top of the loop, okay? So that's what that's doing, is basically saying, okay, you didn't answer something correct, so try again, and then try again, and try again, okay? So that's all that's doing, all right? So you're gonna have to do Y or no or N to be able to actually continue, all right? So that takes care of that. So now if the player wants to hit, what we'll do is to do player card value plus equals random next 1 through 12. And then we'll say card value, random card value between 1 and 11. Okay? Now, what happens if they actually hit 21? Okay, so if the player, so there's a possibility they might bust, right? So if the player is over 21 when they hit again, what we want to tell them is that they have busted. Okay, you busted, and then we want to break out the loop because they are obviously done with their turn. They are busted, and then that's pretty much it. Okay, and then otherwise we want to simply just continue. Okay, now we don't have to put this here, because notice that if we don't put that, what's going to happen is it comes into here and this doesn't execute, and then because this one executed, it's going to go straight into here. Okay, so we can omit this else, but if we don't, it's not going to hurt anything. Okay, so if we come into continue, it's actually going to continue up here, where it's going to come into here, and then because there's no code, it's going to come back here. So they're pretty much doing the same thing, but it's one of those things where if you want to be more clear or not, you can leave it. Okay, so just a little disclaimer there. Now, if you say no, then what you can do is break. Okay, so the answer, so the user does not want to hit again, then break out of the loop, and then their card value will remain where it was before they hit. Okay, so now let's come into out of the loop. Okay, so we come out of the player's turn, and then here is where the dealer is going to. Okay, so the dealer is going to be automatic. Okay, and that's because the fact that dealer we're usually playing against. All right, now at this point, what we can do is we can specify the player's card value. So we'll give them an update. Player's card value is plus player card value toString, and that'll show you the value of the player's card. Okay, of your card. So then we can do if player card value is less than or equal to 21. Okay, in other words, if they have not busted yet. Otherwise, come down here. Otherwise, if they are greater, then that means they're greater than 21, which means they have busted. Okay, so then we can just say the game is pretty much over at this point because the dealer has won, player has busted. All right. However, the player may have not busted. So this is when this condition would execute. Okay, player has not busted. So what we'll do is we'll do another while loop. Okay, so while the dealer's card value is less than 21 and the dealer's card value is less than the player's card value. So while this is true, okay, so what does this mean? While the dealer's card value is less than 21, he's going to keep hitting, and if the dealer's card value is less than the player's card value, he's going to keep hitting, right? And this means that as soon as he hits over, if he hits 21 or over, both these conditions have to meet, okay, for this to happen, for the dealer to keep hitting. Let's write that just to make it a little more clear. Draw a card. Now, see what's going on here is as soon as he hits 21 or over, he's going to stop. Maybe he lost, maybe he didn't. And as soon as he hits over the player's card value or ties it, he's gonna leave. Okay, so if these conditions meet, he's gonna keep hitting, and as soon as they don't, he's gonna stop. Okay, so as soon as he stops, this is when we're gonna check for a winner. All right, so we're gonna say there's a few conditions that we need to check for now. We need to check for if player card value is dealer card value. So have they tied, right? So the player's card value is dealer. And remember, we're only in this block of code if the player has not busted. So we know if we're in here that the player is not has not busted. So he or she is still at or under 21. Okay. Now let's look at what's going on. So player card value equals dealer card value. So what we'll do is we'll write, okay, that means they have tied. So player and dealer have tied. All right. Now that might not be the case though. Maybe they haven't tied. So let's check for and think of another case. And another case that I can think of is player card value. If player card value is less than the dealer card value, and the dealer card value is less than or equal to 21, okay? Because the player's card value may be less than the dealer card value. If we only check for that, that's not accurate, because the dealer's card value can be like, 25. So of course it's going to be greater than the player's card value. However, that means he's busted, so he really hasn't won, right? He or she has not won. So we need to make sure that he or she is not over 21. Okay, so it's less than and equal to 21. So if that is the case, then the dealer has won. All right. Now another situation that I can think of is if the dealer's card value is over 21. Then that means that the dealer has actually busted, right? So the dealer has busted, and remember that we are only in this block of code if the player has not busted, right? So if the dealer has busted and we know the player has not busted, then the player has won. Now the last situation that I can think of is if the dealer's card value equals 21, then the dealer has won. And you might be saying, okay, well, what if the player's value is also 21? Because we know that right here, it might be 21, but remember that the first thing we check for is if they are tied. So if the dealer's card value is 21 and this is 21, then this is going to be tied. If that doesn't happen, that means that these are not the same, which means that 21, the dealer's card value was 21, but the player's card value must have been something less than that. All right, so that means the dealer has won. All right. So notice that the dealer, when you're playing 21, really the odds are in favor of the dealer, really. So with that in mind, I'm like you said, to be honest, I'm not the biggest gambler. So if I did miss some situations, my apologies. But of course, this is not the point of the video. Is just kind of to get the point across of C# and just using the stuff that we've learned so far. So, but these are probably the basic rules, and hopefully most of them have been covered. And of course, now we don't need the switch statement. And notice that why, because it's really important to always ask why I didn't use a switch statement. And the main reason why I didn't is because of the fact that the switch statements, the cases can only be an equal. So you can always do case 1, case 2, not less than, not greater than. You don't have full control over that. And then you can't do, it's hard to do ands, okay? So you'd have to do an and here. So with if and else ifs, you have more control, okay? So of the conditions that are met or not met. So the fact that happened and I needed that, I used if and else ifs here instead of switch statements, where switch statements would be better when I need a simple condition and it'll allow me to write some cleaner code. So those are the situations that I try to go by and judge. And just letting you guys know that for the fact that maybe, if you come across a situation of whether you should use a switch or if in C#, then using that mind thought may help you out. All right. So now that we have the situation, or these situations kind of laid out, let's go ahead and run this and see if we have a working program. So my card value is 13. Okay, so I start off with 13. I'm gonna hit yes, and I'm gonna hit. Okay, I'm at 20, so I think that's a good value to be at. So I'm gonna hit no, and the player's card value is 20. The dealer has busted. Okay, so the dealer has busted, and the player, I have won. Okay, now the dealer busted, but the last thing that I feel that we were missing is the dealer's value. So the dealer obviously busted, so they obviously won over 21. but let's print out the dealer's value so that we kind of have a better judgment of what happened to the dealer. All right, so there you go. Now that'll always print out. So I'm started at 20, so now I'm gonna, I'm gonna stay there. I feel safe. And looks like the dealer wanted to keep trying to match my 20 or beat it, and looks like he or she lost. So I'm in a good position there. Let's play again. This time I'm gonna hit again, and I'm gonna stay at 16. So let's see what the dealer does. So the player card value is 16. The dealer has 1 because the dealer got to 18 and obviously stopped because that's greater than 16, and he or she has 1. Let's play again. So now I have busted. So I've busted. I went to 23, and then obviously the dealer was what I busted, so the dealer didn't have to do anything, and he or she won. Now I busted again. So let's play it safe now. Let's try okay, I am at 21. Okay, so that puts me in a good position, and because it did, the dealer tried to match me and lost. So let's go ahead and set a breakpoint just to see what's going on. And I want to set a breakpoint right here when this is when the dealer starts drawing and hitting. So let's start the program, and let's hit, and it looks like I busted. So let's try it again. So I am at 20. So I'm actually going to stop, and then it's going to come into this code, okay? And notice that down here we have our values, and this will help us with debugging C#. The dealer's card value is 2, so the dealer is really low. So he or she's going to keep hitting. Now they're at 12. It's going to keep hitting because the player card value is 20, so they are trying to beat it. And the dealer card value is 21. So they hit 9, and then they hit 21. So now that the dealer card value is not less than the player card value and not less than 21, the dealer will no longer hit, and it'll come into here and see that it is greater, and then it is equal to 21 at least, so the dealer has in fact won. Okay, so stepping through the code sometimes helps me and hopefully helps you to see what's going on in the inner workings of the code, and obviously sometimes point out some bugs and see what's really going on, since debugging is the very term of it kind of gives that away, of course, but that does help me to clarify sometimes, even when there's not a bug, to see what's going on. So, but there you have it, guys. I mean, everything that we have learned so far, and hopefully I was thorough enough with what we have learned and using those tools that we now have to build a simple 21 blackjack game. All right. So in the next few tutorial series, we'll learn some new stuff. So probably like a raise, and we're going to go over a few other things, like starting with types and creating types and enumerations. And once we get further in, we'll dive into some lightweight WPF and start kind of making this giving this a GUI and a visual aspect to our code. And of course, to me, that always makes it funner as well. All right. So as always, thanks for watching, guys.